Okay, we have written another integral on the board. We've got the integral of x squared plus 1 over x to the fourth plus 1 dx. Okay, to get started with this, the tricky thing is just having x to the fourth here. And unfortunately, it's not x to the fourth minus 1. If it was x to the fourth minus 1, we could use difference of two squares and get some cancellation. So unfortunately, we have a plus here, and so we can't do that. But another thing I like to do when we have x to the fourth is if I multiply through everything by 1 over x squared over 1 over x squared, I'm just multiplying by 1, but this will kind of transform it. So let's see what happens. If I distribute it into the numerator, 1 over x squared times x squared is going to give me 1, and then we're going to have 1 over x squared here. Then in the denominator, multiplying in 1 over x squared to the x to the fourth, I end up with x squared plus, again, 1 over x squared. But now looking at this numerator right here, 1 plus 1 over x squared dx, it's making me think u substitution. It's kind of like I already know what u substitution I want before we have it set up. So if we had a u substitution, if we could do this and we had x minus 1 over x, well, we don't have that in the integral, but the derivative of this, if we find our du, derivative of x is just 1. Derivative of minus 1 over x is going to be plus 1 over x squared. So what happens is our numerator is already this du right here. We just need to somehow create this x minus 1 over x in the denominator. Well, what I can do is kind of force this to happen. We'll rewrite the numerator right here. Now I want this, so we're going to write this, I'm going to create x minus 1 over x all squared. Now if you square this out, you're going to get x squared plus 1 over x squared, but then the middle term is going to give me a minus 2. Well, I don't want to change it, so we'll just add a 2, and that way this here in the denominator is exactly the same as this here. But now that we have this set up the way we want it, we can do our u substitution. So again, the whole numerator is going to be just du, and this is going to become u squared plus 2. But what I can do with this 2, we'll just rewrite this as square root of 2 all squared. And now this is perfectly set up for our arctan formula. If we have an integral like dx over x squared plus a squared, this is just going to be 1 over a arctan of x over a. So using this here where our a value is going to be square root of 2, so just using this formula here, we're going to end up with 1 over our a value square root of 2, and this is going to be arctan of u over square root of 2. And so we just need to back substitute. But one thing I'm going to do before I do that, let's kind of clean this up a little bit. What I'm going to do is I'm going to get a common denominator. I can kind of multiply by x here and x here. So this becomes x squared. So writing this out, we're going to end up with x squared minus 1 all over x. And so now we'll back substitute that. I'll come all the way over here. So for my final solution to this, we get 1 over square root of 2 arctan. Then we'll have and then we'll use this. We're going to have x squared minus 1 over square root of 2x, put a plus c, and that's it. Okay, so there you have it, dealing with x to the fourth by multiplying in the 1 over x squared. Thanks everyone for watching. Have a good day.